Hey Whitehill, hope you had success walking your way through the steps of the lesson with the main goal of discovering why the Earth has seasons. So the models you looked at had lots of different pieces of evidence, and hopefully you found them. I'm here to provide you with a little modeling demonstration to help support that in case you weren't quite there or just to help you get a better visual. So what I have in this demonstration are a few items to work with. I've got a sun right here. It's just a light bulb that will provide a little bit of heat. And we're going to be able to identify heat by using thermal paper. Oop, that's got a weird reflection. As I bring this heat up, you can see the paper turns green. If I bring it up closer, it kind of turns a bluish green. You can see that blue right there in the middle. Another visual could be my thumbprint from my body heat. Should leave a little mark as well. Now it takes a minute or two, and as it cools back down, it will go back to its original kind of reddish tint. So the final piece of this demonstration is I have a globe here. And as you can see, hopefully one of your observations was that the Earth rotates, it spins on a tilt. There was some indications of this on the model. It is a 23.5-degree tilt. You can see the little metal piece down at the bottom and at the top, and that's where it spins around. So it doesn't spin perfectly evenly. The equator's at a 23.5-degree tilt. That's this dark blue line indicates that. So you may have also noticed I have little strips of thermal paper on here to help show where there is more heat. So we're going to take this metal bar and have it face in one direction the whole time so that that tilt we know is being constant as the Earth spins around. So I'm going to point it away from us. That would be towards the east if you knew where we were in my house. And so right now, when you want to look at where the United States is, it is, whoops, I'm moving that. It's up top here. So at this point in Earth's orbit from the sun, we would call this winter because it is sort of angled away from the sun. It does not have a direct angle of sunlight. So that energy has to get dispersed over a lot of ground. It spreads out, if you will. It is not simply because it's further away from the sun, because that's only a matter of hundreds or thousands of miles further away from the sun than the equator. And we know that during this time of the year, it's actually millions, 3 million miles closer during our winter. So when you get a horizontal sun, which is coming in right here to shine, the area of the Earth that is more directly facing is going to get that more heat. You can see it turning green there before it will only slowly fade up towards the top. So now as we rotate, as we orbit the sun, the Earth of course is constantly spinning. I'm going to keep this bracket pointed in the same direction as it's coming around. It's now rotating around me. I'll be the sun. And now that bracket, we're on the other side of the orbit, so that bracket is now facing us because it's still pointing in that same direction as it rotated around me. And as the Earth spins, you can see now that the United States, the northern hemisphere, has a much better angle. That equator is sort of dipping down, and the most direct spot to the sun is actually just above the equator. So here's the sun coming in at its direct angle, and you can see the equator and on up turning nice and green first, indicating there is more heat energy there. So get it nice and green. There we go. So ideally, from those models, you were able to walk away with the tilt. I'll turn the bracket to this side now just to show that tilting angle as it rotates, is the cause of the seasons on Earth, because at different points in the orbit you get more direct sunlight. The distance, while distance does play a role in temperature from the sun, it is less of a variable than that direct angle. Okay, I hope you enjoyed this model. There's another video following this by California Academy of Sciences. Provides very similar information with some animation. So please check that out and as you wrap up this lesson. Okay, take care, Whitehill.